Well, one of the neat things about mathematics as a thing to study, as a discipline, is that pretty much everything that we know in mathematics has been mathematically proven. We don't really just take things on face value and say, oh, well, that's true. No one just looked at the law of sines and said, you know, this seems right. Let's just go with it. It's been proven to be true, and it is true, and it does work, and we're about to prove that it works, and we're going to do that in number 7. You have to know for sure that it works before you do it. There is a logical flow to mathematics. It may not seem that way. So, for reasons that will become clear, let's draw that. That is the altitude to side AB from angle C. We're going to make it the altitude by drawing a right angle right there. Okay, suddenly we have two right triangles. We have the one on the left and the one on the right, and just so we can keep up with a few things, let's label some sides. This entire side is going to be big C, little c. However, if we wanted to split some things up, we can call this one little e, we can call this one little f, and we can call this one little g. Okay? So, using some stuff that we know, let me cover some things up here. Let's cover up that side with my funky colored post-it note. If we covered this side up, and I wanted to just use sine. Why do I want to use sine? Well, I'm proving that the law of sines works. So, trust me on this, I'm going somewhere. So, sine of A, capital A, is equal to opposite over hypotenuse. Okay, so in relation to this angle A, that's the opposite and that is the hypotenuse, and what I just wrote is a true statement. Okay, so let's come over here and do the same idea. Let's do this with sine B. So sine of big B equals opposite, well, what's opposite big B? Little f. Over hypotenuse, which is little a. Okay, well, what good does that do me, Mr. Reader? You're about to find out. One of these random things I notice, and you probably notice it too, both of these have the exact same variable in it. What variable do they share? F, of course. Now, this one has a big A, and that one has a little a, and that one has a big B, and that one has a little b, and all that good stuff, but they both have a little f. They both have this side right here in there, that segment right there. So we should, just because it seems like the right thing to do, sometimes in math when you're proving something, you just explore and go with it. That's how a lot of math happened. People just explored. So sine, or B sine A. What we're doing is solving for F, just because. And then we'll solve for F here. If we're solving for F in either one of these, we'd multiply by that denominator and get it out of there. So there we go, we have that. Okay, well, if this equals F and that equals F, then they must equal each other. If two different things are equal to the same thing, then they must equal each other. So we're going to do that. We're going to say that B sine A equals A sine B. Notice the emphasis on the uppercase letters. Alright, I'm about to do something fantastic, and when I do this, you're going to say, wow, that's the law of sines. And sure enough, it does work. And you could extend this further to include big C and little c. We're not going to, but you could. If we divided this side by B, we'd have to divide this side by B, and it would cancel those out. And we would have sine of A over, let's put it over 1 just because I want to. And then we'd have A sine B over little b. Is this starting to look like the law of sines? I believe so. Let's divide this by A. It'll cancel that. Yes, what I did was perfectly legal. We'll divide this by A, and I don't have to have this 1 here, so technically I have this and I have this, and I just proved that the law of sines is true. Why do I need to know that? Because it helps me understand the logical flow of ideas, not just in mathematics, but in other areas as well. So there you go. That is why the law of sines works.